Hi everyone, welcome to the third lesson for topic 3.2 growth and decay in sequences. So for this lesson, we are going to talk about the geometric sequence. So in the previous lesson, we have discussed what is that meant by sequence, then what is a recursive rule. Then after that, we talk about one type of the special sequence, which is the arithmetic sequence, right? So I'm going to finish off the theoretical part, which is more on the calculation part. Then after that, we only move into the application part. So for today's objective, it will be on geometric sequence. So similar like arithmetic sequence, you are going to look at what is that meant by geometric sequence, then how do you use recursion to generate a geometric sequence, and also how to write the rule for the n term if let's say you want to jump over the sequence. Okay, so now let's try to do a quick recap on what we have learned in the last lesson. Okay, so previously we talked about the first type of the sequence, which we have it as arithmetic sequence. So arithmetic sequence is a sequence of numbers such that the difference between any two successive term would be a constant. And we actually call that constant as the common difference. Okay, so I hope that you still remember like all these special terms that we have here. So the common difference is normally denoted by D. Okay, and how do we find the common difference? We try to use any term to minus the previous term, then this is how you get your common difference. So you see when you have an increasing sequence, right, then when you use a term to minus the previous term, then you are getting a positive D. So if let's say the sequence is decreasing and you are using a term to minus the previous term, then you should be able to get a negative number. So that's why it's like plus a negative number, then it becomes subtracting. Okay, but we normally say that it's like adding, but it's just that your D is positive or negative. So the recurrence relation for an arithmetic sequence, it will be the term, okay, and then your previous term plus your D. Okay, I'm sorry, n minus 1. Yeah, so for you to get any future term, any subsequent term for your arithmetic sequence, you are using your previous term and then plus what is your common difference. And don't forget your T1 equals to A. Okay, so for recurrence relationship, two things, right? The rule and then what's the initial term. So the general rule of Tn, the n term for the arithmetic progression is written as Tn equal to a plus n minus 1d. Okay, so this is a thing that you should be pretty familiar, which the a represent the first term and the r is the common ratio. So the difference between the recurrence relation and the general rule is that recurrence relation, you must have your previous term so that you can get your subsequent term. But for general rule, you can jump to any term as long as like anyone that you like, as long as you have the general rule here. Okay, so for this lesson, let's start with the geometric sequence and what's the definition of it. Alright, let's start with the definition of geometric sequence. So a geometric sequence is a sequence of number where each number after the first one is found by multiplying the previous one by a fixed non-zero number. Okay, multiplying. So this constant number that we use to multiply is known as the common ratio. So I hope that by this time you'll be able to recognize the difference between a geometric and also a arithmetic. So for arithmetic, right, how do you get the subsequent term is by adding something. But for geometric sequence is multiplying something. So that's why when we try to talk about the relationship between the term and the previous term, right, it should be a division. So that's why it's common ratio. But when we talk about the arithmetic progression, it's like a difference. So that's why it's called as common difference. So how do we get the number of r is by dividing the preceding term. Okay, so use any term divided by the preceding term. So which means that we are going to, if let's say you have this current term, you are going to use it to divide by the previous term so that you can get your R. Okay, so that's the idea. So now let's look at example 1. So to look at some of the geometric sequence that we have. Okay, example 1, continue the sequence, determine the common ratio and form a recursive rule for the sequence here. Okay, so as you can see, I think for the first one is quite easy. So let's try to find out the common ratio first. So as what I mentioned previously, you can take take any term, divide by the term previously, then you should be able to get your common ratio. So in this case, then we can see we have our R will be equal to, so take any number. So for example, I get the first one and the second one, then it will be 6 and then divide by the previous term, which is 3. So I'll be able to get 2. So which means, what's that mean? How do I get all the preceding term? Is by multiplying 2. Okay, so that's the idea. So which means 48 multiply 2, then I'll be able to get 69. Then multiply by 2, then I'll be able to get 192. Okay, so what is the recursive rule for this? So I hope that you should be very familiar with this already. So which is the nth term is equal to the previous term and then multiply by 2. So that's why you can write the 2 in front. Okay, so it's like 2 times Tn minus 1. And don't forget your T1 is equals to 3. Okay, so that's basically for the first one. Okay, for the second one, you will realize that normally if we try to solve it in terms of sequence, right, we will say it's divide by 5. But you remember just now, we always say that it's common ratio, so it's multiplying something. So we normally do not say like divide what. So the same thing, how are we going to find the ratio? We're going to get any number divided by the previous term. So maybe this time we try to get 400. So 400, then I use it to divide the previous term, which is 2000. So from here, then I'll be able to get 1 over 5. Okay, so you see it makes sense, right? Divide by 5 actually means multiply 5. Or in the other words, you can also do multiply 0.2 as well. So which means 50,000 need to multiply 1 over 5 to get 10,000. Then multiply another 1 over 5, then you get 5,000 or 2,000 and so on. So 400, when you multiply 1 over 5, then you should be able to get 80. Okay, or it's the same thing when you multiply 0.2 as well. Then when I do it again, then I'll be able to get 16. So when we try to write out, then the same thing. How do I get the n term? I use the previous term and I multiply 1 over 5. Okay, so again, let me repeat. When we try to denote GP, we wouldn't say that Tn minus 1 divide by 5. So we will always say multiply instead. Okay, so it will be T1 is equal to 50,000. Okay, so now let's move on for the next one. So this is a bit special. So you can see that's like alternating sign of your number here. So positive, negative, positive, negative, positive. Okay, so by looking at this sequence, you should be able to get that your ratio is actually a negative number. So you see how it goes is when you multiply a negative number, you get negative. When you multiply a negative number again, then you get positive. After you get positive, you multiply negative, then you get negative again. So this is the idea why the sign is not alternating. So same thing, you can use any term, then you divide by previous term. So maybe I use 18, then divide by negative 6. Then I'll be able to get negative 3. So you can see how do I get the preceding term is by multiply negative 3 every time. Okay, so when I move on, then I'll be able to get negative, right? And then negative times so 6 and then 16 times 3 is going to give us 48. Okay, then after that from this term as well, then we multiply negative 3 and that's going to give you a positive. So 486 multiplied by 3 and you're going to get 1458. Okay, so after you got this, then now write down the recursive rule. Then how do you get the current term? You use the previous term and multiply negative 3, right? So negative 3t and minus 1. So our first term is 2. Okay, so let's look at the next one. So negative 27, 9, negative 3, 1, negative 1 over 3. So you can see this is alternating as well. Then you can expect that your R should be a negative number also. So take any one. So maybe you can take 1 divided by negative 3. Yeah, then this one is easy. Your ratio will be negative 1 over 3. So which means how do you get the next term is multiplying 1 over 3, which in the term is like divide 3. But we don't say divide 3, but multiply 1 over 3. So when we move on, sorry, it's negative 1 over 3. Okay, so when we move on, then we'll be able to get 1 over 9, then multiply negative 1 over 3, then negative 1 over 27. Okay, so when we try to write down the recursive rule, then it will be Tn equals to negative 1 over 3 times n minus 1 term. So the initial term is negative 27. Okay, so before we move on to the next part of the notes, right, I just want to go through this slide very quickly with you to see the pattern of this different sequence. Okay, you see for the first one, right, you can see that the sequence is actually increasing. Am I right? So when you have a ratio that the number of your common ratio is greater than 1, you are going to get a GP that is increasing. For the second one, you see, when you have a ratio that is a number that is bigger than 0 but smaller than 1, okay, then you will be able to get a sequence that is decreasing. Because you see, if you multiply with 0 point something, then you can definitely get a number that's smaller than the previous one, right? So that's why this is decreasing. Okay, when we try to look at these two, when you have a negative number, then you can see that the number is actually alternating. So going up, going down, going up, going down. But what's the difference between these two is that you can actually see the same pattern. So the difference between these two are is that this is negative 3 and this is negative 1 over 3. So 3 is greater than 1 over 3 is smaller than 1. So when you have a greater 1, right, then if we try to ignore the negative sign, you can still see the number is actually increasing, right? So you can see 2, 6, 18, 54, 1, 6, 2, and so on. The difference is just that now you have a negative sign, so that's why it becomes alternating. Same thing, when you have 1 over 3, it's like a number that is greater than 0 and lesser than 1. So that's why you can see the number is decreasing. So when you ignore all the negative sign and you try to look at this number, the number is actually decreasing. But it's just that now negative so that your number become alternating. Okay, so that's the idea. Later we are going to write down some notes about this. Okay, so now let's try to write down the general rule for the recurrence relation. So in general, you can see that geometric sequence has this sequence. So how do you get the next term is by multiplying the common R. Then when you get the third term, multiply another common R and so on, right? So that's why you can see that the recurrence relation for a GP will always be how do you get the current term? You use the previous term and then multiply by R. Okay, so that's how you get it. And you don't forget that you need to write your initial term, which is your T1. So in this case, A is the initial term, and also R is what we find out by dividing the current term with the previous term, and R is called as the common ratio. Okay, so yeah, I have put it here. It means that each subsequent term is obtained by multiplying R to the previous term. Okay, so this is the thing that I mentioned by using the previous example. So if you get a R that is greater than 0, then you can imagine that the sequence is increasing. So you can try with your calculator lah. So you can use any number that's greater than 1 and you use to multiply a number, right? Then definitely the number, the product that you get should be a number that is greater than your original number, right? So if your R is between 0 and 1, which means you are getting a decimal which start with 0 point something, then it's similar like when you write in fraction, then the fraction is like smaller than 1. So that's why the sequence is decreasing. Okay, so imagine when you use 10 to multiply 0.5, multiply 0.8. So any number that's lesser than 1, that's going to give you a number that's smaller than your original number. So if your R is smaller than 0, which means the R is a negative number, then the sequence will be alternating between a positive and the negative number. Okay, so the idea is just that the magnitude itself, after you ignore the positive and negative, when you try to look at the sequence, you still can identify the pattern of increasing decreases by looking at what is the number of R that you have there. Okay, so if you are dealing with like negative 0.5, then you can see it's alternating, but the number, the value itself is going to be a number that's getting lesser and lesser. If let's say you are dealing with negative 5, the number is alternating, but the value itself is still increasing. Okay, so you can actually look at this idea in a much more clearer way when we talk about the graphical form for arithmetic sequence and geometric sequence when we move on to the future lesson. Okay, so now let's move on to example 2. Okay, example 2, state the first 5 terms, identify if the following recurrence relation generate a geometric sequence or not. Okay, so I hope that actually just by looking at the recurrence relation, you should be able to identify whether it's a GP or not, right? So if let's say it's not, then you should be able to know it's not. But the question wants us to state the first 5 terms, then you can, do some exercise on how do you write down the first 5 terms for the recurrence relation. So for the first one, we have the first term is 5. And how do you get the next term is by multiplying 3 to the previous term. So that's why we have 5. And the next term will be 15, right? So you multiply 3. And after you multiply another 3 again, then multiply another 3 again, then multiply another 3 again, then you'll be able to get 405. Okay, so that's the idea of it. So after you got this, then now you can try to check again. So either you try to look at the recurrence situation, or you try to see whether there's a common ratio or not between all the numbers here. So that's why you see, how do you get all the next term? You is by multiplying 3, right? So 3 is your common ratio. So that's why yes, it is a GP. Okay, then the second one, by looking at this recurrence, then you should be able to see that it's a GP also. Okay, but let's try to write down the term. So you see this is a negative common ratio. It's 4, so that's why you are going to have a alternating sequence. So we start with 4, multiplying negative 5, negative 20, multiplying negative 5 again, so 100, negative 500, and then 2500. Okay, so in this case, just now we already said that it's a yes. Okay, C, so you can see this common ratio is a fraction. So when you use to multiply, then you should be able to get a set of number that is decreasing. Okay, so I hope that you can see the pattern now already. Please do not have the mindset that if it's a fraction, then it's going to give you decreasing. Okay, this fraction must be a number that is less than 1. So for example, 3 over 5 is like 0.6. So that's why only it's decreasing. If let's say it's something that maybe 5 over 2, so this is going to be 2.5. So the common ratio is actually greater than 1. So in this case, you are still getting an increasing sequence. Okay, so now let's try to do this. So the first term is 50, right? So when we multiply by 0.6, or you can do divide 5, multiply 3, or you can just use your calculator to help you to do that. So you can get 30, then multiply 0.6 again, that's 18. And after 18, then we have 10.8, then multiply another one, or 0.6, then you can get 6.48. Yeah, okay. So by looking at this recurrence relation, and we already know that it's a yes, okay. Yeah, then now the next one, so you can see it's a negative, but now compared to this one, the common ratio here is negative 5, but common ratio here is negative 0.2. So that's why it has a alternating sequence as well, but then the magnitude, the value of itself should be a number that's like getting lesser and lesser. So that's why we start with 11, right? So this one, I think you can try to use your calculator to help you to do that. Okay, so 11 times 0.2, and you'll be able to get negative 2.2. Okay, then move on again times another negative 0.2, and that's 0.44. Okay, move on to the next one, and what do you get? Then you can get 0.088. Then the next one, it will be 0.0176. Oops, I'm sorry. I think I do some. Yeah, this should be positive. Okay, so make sure that you are doing it correctly. So this is comma, yeah, positive, then this is negative, then this is positive. So you can try to check again by your calculator when you try to divide all the term with the previous term. Is it able to give you a number that is the same, which is negative 0.2? So in this case, this is a yes also. Just by looking at this, then you'll be able to know whether it's a GP or not. Okay, E. So you can see that for this case, how do you get the next term? Is multiplying 4 and plus 2. So that's why you cannot, I mean, although you know plus together is like arithmetic, multiplying is like a geometric, but when you try to combine them together, it will be neither arithmetic nor your geometric that you have. Okay, so in this case it's a no. But then let's try to form the equation maybe. So 5 multiply 4 plus 2, then you have 22. Then another multiply 2, then we can get 90. Multiply 4 plus 2, then 362. Then 362 multiply 4 and then plus 2, and we'll be able to get 1450. So you can see that when you try to look at this, right, they do not have a common difference, and they do not have a common ratio as well. although they are getting this is called as a sequence because you actually get it you actually can get it by using a recurrence relation, right? But it's not AP, it's not GP, it's just a normal sequence that we have. So this is no. Okay, so now example 3. Okay, for each of the following sequence, state that whether the sequence is a geometric sequence or not. So for those that is a geometric sequence, then state the initial term, the common ratio, and the recursive formula. Okay, so you might need to remember to really check everything. So 15 divided by 3, then you get 5. 75 divided by 3, sorry, 75 divided by 50, then what can you get? Yeah, you can get 5 also. 225 divided by 75, and you get 3. So that's why actually this is not a GP. The idea is you can try to see 15 divided by 3, then you get 5, right? 75 divided by 15, what do you get? Yeah, you still get a 5. But when you move on to the next one, when you use 225 to divide by 75, you realize that it actually gives you a 3. So that's why this is not a constant number that you multiply. So this is no. Okay, the idea is there's no common ratio. Or you can say that the ratio is not common lah, no common ratio. Okay, so move on to B. So same thing, let's try to check everything. So 12 divided by 48, and that gives us 1 over 4. 3 over 12, and that's 1 over 4 as well. 0.75 over 3. Then this one you might need your help of your calculator to help you to do that. So yeah, you can get 1 over 4 as well. So that's why yes. Okay, and let's write down the initial term. So the A is 48. So the R is what we find out just now. The R is 1 over 4. Then the recursive formula here is going to be Tn equals to what's your, yeah, so you multiply by 1 over 4, right? So 1 over 4 times n minus 1 term. And the first term is 48. Okay, so the C, okay, 150, 90, negative 54, negative 32.4. Just by looking at this, you can already know that it's not a GP. Why is that so? Because when you use 90 to divide by 150, that give you positive. But you use negative 54 divided by 90, you get a negative number. When you use this one minus divide this one, then you get a positive number again. So that's why in this case you so whenever you have a R that is a positive, right, the sign wouldn't change. If let's say your R is a negative value, then it's going to be alternate like positive, negative, positive, negative. It wouldn't come out in this pattern that you have like two positive, then two negative, two positive, and so on. So that's why there's no. Okay, so the same thing is like no common ratio. So you can try to check it out and see whether what I say here is correct or not. Okay, so you can see like 90 divided by 150, right? Then you can get 9, so 3 over 5. Okay, then negative 54 divided by 90. So from here, then you already get a different thing already because definitely you are going to get a negative in your answer. So it's still 3 over 5, but it's negative 3 over 5. So the common ratio is not the same. Okay, so now example 4. Okay, example 4, the fourth term in a geometric sequence is 128. So the first term is 16. The question wants to find out the common ratio. Okay, so in this case, we are just going to use what we have learned so far. So we are not going to use any rule of our nth term to do this. Okay, so you can imagine we have our first term is 16. Then after that, our fourth term is 1 to 8, right? So you can imagine between the first term and the fourth term, we have the second term and the third term. Okay, so what's the difference between them is the common ratio, right? So from D1 to D2 is like multiply and R. So from here to here is multiply another R. From here to here is multiply another R as well. So that's why you can see how do you get to 128 is 16 need to multiply 3 times of R. So when you try to write down, that can be like 16 multiply an R, multiply another R, multiply another R, and that gives you 128. Am I right? So, or in the other case, then you can see that that's like 3 times of R, so R cubed will be equal to 128 divided by 16. It's just going to be the exactly same thing. So when we multiply them together, then we can get 16R cubed, then equal to 128. Okay, so we bring 16 over the other side, then it will become divide, right? So 128 divided by 16, and that will give us 8. So R cubed is equals to 8. Okay, so R is equal to 2. Okay, because square root of 8 give you 2. So I think that is easy, right? So after we got this, then now we can state the recurrence relation. Tn equals to times 2, the previous term, and then our first term is equal to 16 in this case. So after you get this answer right, you can actually check it by using what you have here. So for example, it's times 2. So you check and see whether it's correct. 16 times 2, 32. 32 times 2, you get 64. So that's why 64 times 2, you get 128, which you know that's correct. Okay, so now we will try to derive the general formula for geometric sequence as well. Okay, so similar like arithmetic sequence, we can also create a rule to find any term in our geometric sequence as well. So I hope that you still remember. So this is known as the general formula, or sometimes we say that is the n term rule for the geometric sequence. Okay, so yeah, because you can see that they are referring to the different sequence, they have the different recurrence relation as well. So that's why you can imagine that the Anton rule will be a different one also. Okay, so let's try to look at the sequence that we have here. So we have the first term is 2, second one is 6, and so on. Then from this sequence, right, we can actually see that the common ratio that we have here is 3, right? So how do we get 6? It's like 2, then we multiply by 3. Okay, then how do we get 18? It's actually by using the previous term, which is 2 times 3, and then we multiply another 3, right? So we get like 6 times 3, and we get 18. So it's the same thing over here. So 2 times 3 times 3 times 3, then we can get 54. Okay, so now when you try to look at it, like calculate how many r do you need to multiply, then what do you have? So for the first one, it's like 2, and then 3, I multiply with 0, 3. So that's why 3 to the power of 0 actually gives us 1. So that gives us 1 multiplied 2, and that's 2, right? So 2 multiplied by 3, so which means 2, I multiply with 1 times of 3. When I say 2 times 3 times 3, that is going to be 2 and then 3 to the power of 2, right? I multiply 3, 3, so that's why like 3 squared. So for this part, then I multiply 2 times or 3 times of 3, so that's why it will be 2, then 3 to the power of 3. Okay, so I hope that you can start to see the pattern now. It's the same thing. You can see that for every term that you have, right, our A is the same, which means it's a 2 here. 2, 2, 2, 2. And the R is also the same, 3, 3, 3, 3. What changes is the power on the common ratio, which for your first term is going to be 0, for your second term is 1, for your third term is 2, for fourth term is actually 3. So if now I were to get the 50 term, then meaning that it will be 2, 3 to the power of 49. If I need to find the 100 term, then it will be 2, then 3 to the power of 99. So it's like the term and then minus 1, right? So that's why for the general term, if I'm finding like t to the n term, then I'll be doing like 2, 3 to the power of n minus 1. Okay, so now let's try to look at it in the general approach. So now we are trying to write down it in the general form by using the notation that we have, the A, R, and also N. Okay, so how do I get the first term is just A, right? How do I get the second term is A times R. Okay, so that's why I have AR. Then when I move on to the third term, then I need to do A times R, then times another R, right? So that gives us AR squared. Then when I go to the fourth term, then it will be A times R times R times R. Okay, so that actually gives me AR power 3. So when I move on to 50, then it will be AR power 49. So go to 100, then it will be AR 100 minus 1, so 99. Then when I want to find Tn, so you can see that I'll just do the same thing, which is AR, right? Then after that, what's the power that I need to put here? It's one number less than the term, the n that you want to find. So that's why in this case is n minus 1. So that's why what is the general rule for our geometric sequence in terms of the n? Then it will be Tn equal to AR n minus 1. Okay, so what is our A? A is the initial term. And what is our R? R is our common ratio. Okay, so similar like the arithmetic sequence that we have. So the anthem rule actually allow us to jump to any desired term without determining all the preceding term. So recursive rule, we express the n term in terms of the n minus 1 term. So we need the previous term for us to get any current term. So for general formula, we express the n term in terms of n. So as you know which position of n that you want, then you can straight away substitute your n, then you get your n term. Okay, so now let's look at the example. Okay, state the initial term and the common ratio for each of the geometric sequence, then find the 8 and the 15 term. Okay, so now the same thing. So let's try to do 8 is equals to 7. So common ratio, just take any number. So 21 divided by 7, then we can get 3. Okay, so write down the we need to write down the n term so that we can find the 8 and the 15 term, right? If not, you are just going to continue to write up to 14 term to find 50 term. So now Tn will be equal to AR to the power of n minus 1. Okay, so the A here is 7, so R is 3, so n minus 1. Okay, so this is how you can leave your answer. Of course, if you have another alternative that you want to simplify it, then what you can try to do is you can continue to split this up, but for this one, you will need to have some basic knowledge in indices. And I don't think that's really required in your syllabus here. But please remember that when you try to write like this, right, meaning that the 3 to the power of n minus 1, the n minus 1 doesn't belong to 7. So please do not combine these two together and tell me 21 n minus 1. That's super wrong. Okay, so don't do that. So if you really want to get it simplified, then what you can try to do is that you can try to split this if you have some knowledge in indices. If no, then just leave your answer like this is good enough. Okay, if you want to continue, then it will be 7. So for this, you know that you can split it into 2, 3 to the power of n, and then 3 to the power of negative 1. So 3 to the power of negative 1, you know that you are getting 1 over 3. So when you multiply with 7, then you can write it in 7 over 3, and then 3, then 3, and just like that. So it's the same thing like the previous one. But like what I said, you can just leave your answer in this term, or it's good enough. Okay, so we want to find the T8. So now we are going to substitute. So T3, so n minus 1, now the n is 8, right? So that's why 8 minus 1. So you can just use your calculator to help you to do that. So 7, 3 to the power of 7. So 7, 3 power 7, and then multiply by 7. So we can get 15309. Okay, so the next one, the 15th term, so it will be T7, 3, n minus 1, then 15 minus 1, right? Then we can get 14. So 7, 3, 14. Okay, so by using our calculator as well, then we can multiply 7, then we can get, this is a very big number, 33480, then 783. Okay, so now let's try to use our calculator to help us to check maybe. Okay, I hope you know how to do your sequence already. So now let's try to key in them together. So we try to use the generate sequence, right? So data generate sequence. So now we can try to key in our formula here. So let's try to key in the first one first, which is this one. Okay, so 7 and then bracket 3, okay, to the power of. Then how are you going to do that? You can see this sign, right? So power of, then after that you just put in n minus 1. Okay, you're following, right? So after you key in this, then after that you can key in your first term, which is going to be 7. So now you just tap everything, then okay. So calculator will help you to generate everything, then you can see that you get exactly the same thing like what we have here. 7, 21, 63, 189, and so on. So we want the answer for the 8th term, right? So that's why 1, 2, 3, 4, 5, 6, 7, 8. So let me try to, yeah, so the 8th term is like here. So that's why 15309 is correct. Then after that, this one is for 15. So we move on for 15. Then you know that this is correct as well. So you can read the whole number here. Okay, so this is exactly what we found here. Okay, so now let's try to see what happened if let's say I try to key in the one that I simplified just now. So which means this one. So you will see that it's actually the same thing. So menu, data, generate sequence. Okay. Then after that, I just key in the same thing here. So 7, okay, 7, and then you can press over 3. So you can get it here, right? If you need anything that you cannot see in the function here, then you press this. Okay, let me try to do it again. So let's open a bracket. Then you want to key in a fraction, right? So you just press this bottom. You can see that there's a icon beside the book. Okay, so after you press this, then it will come out everything. So you can see that what you want here is fraction, right? So that's why you just press this. Okay, then it will come out something like the slash thing. So that's why you are just going to put like 7/3. Okay, then after that, you multiply 3 with n, right? So that's why 3 and then to the power of n. So same thing, power and then n. Okay, so yeah, I hope that you are trying that in your calculator by not watching it only. So initial term is 7, so you type everything, then okay, then you should be able to get the exactly same thing like what you have in your first column. Okay, so that's pretty much of it. So now let's move on to part B. Okay, so Tn, the n plus 1 term is equal to 2 times the previous term. Okay, so I think this is very direct as well. Then we can surely get our answer. So Tn equal to AR, the let's try to write down the A and the R first. Okay, so the A here is 7, and the R here, you can try to read it from the recursive, right? So how do you get the next term? You use the previous term times 2. So your common ratio is just 2. So Tn is equal to ARn minus 1. So in this case, our A is 7, R is 2, and then N negative 1. Okay, so same thing, if you want to expand it, you can try yourself, but you can actually just stop here. If you want to continue for the last one, like simplify like this, then you can actually get 7 over 2 and then 2n as well. Okay, but you can actually just stop here. Okay, so same thing, we try to do our T8. It will be equal to 7, 2, and then 8 minus 1. Okay, so you can try to use your calculator to do that. 7, 2 to the power of 7. So we can get 896. So T15, so 7, 2, and we have 15 minus 1. Okay, so that's 14. So you just change in the power part, then you'll be able to get 114688. Okay, so same thing, let's try to generate this in our calculator maybe. Okay, so for this one, we can try to do that. Okay, menu, then data, generate sequence. Okay, so now key in the equation that we have. 7, 2, okay, and then to the power of n minus 1. Okay, so after you get this, then initial term is 7, right? So make sure you type in all the correct thing here. So when you move on, then okay, then you get the exactly same thing like what we have for the answer. Okay, so T8 is 896. So T8, yeah, so 896. Then after that, T15 is 114688. Okay, so that's correct. Okay, you can see another thing that you can try to check this because this one is also based on the recursive, right? So let's try to key in. If we try to key in recursive, then what happened? So we can do data generate sequence. Okay, so now we try to use recursive. So this is like your un. So when we key in, then it will be 2. Then you multiply with your previous term, right? So un minus 1. Okay, the recursive, if let's say Tn plus 1 represented by Un, then which means your Tn will become Un minus 1, right? Then after that, your initial term is still 7. So when you move on, then you'll be able to get the exactly same thing as well. Okay, as you can see over here. Yeah, so which means no matter you are using recursive or you are using the anthem, it's still going to give you the same answer. But then this is very helpful if let's say you want to get something that you do not have your preceding and you want to jump, especially if you do not have your calculator, then this is the method that we will be doing. Okay, C. So the term starts with 80, each term obtained by dividing 4 to a previous term. So if you can recall, I said that previously, there's no such thing as dividing in our GP, so it's just multiplying. So that's why the A here is 80. Divide 8, divide 4, what does that mean? It actually means that it's multiply 1 over 4. Okay, so I hope that you are very familiar with this idea. So Tn is equal to ARn minus 1. So our A here is 80, R is 1 over 4, and n minus 1. Okay, so you can stop here, or if you wish to continue, and I believe you will get 4 negative 1, so that's 1 over 4. Then, sorry, 1 over 4 negative 1, that's give you 4. So I guess you will get 320, and then 1 over 4 power n. Okay, you can just try it out. Okay, so now let's move on. So what we have here is, sorry. Okay, so what we have here to find T8. Okay, so same thing, substitution 80, 1 over 4, and then 8 minus 1. So same thing, we use calculator to help us to do that. So 1 over 4, and then yeah, because I mean multiply 7 times, this is a bit difficult, so that's why they wouldn't actually come out this kind of question in your paper as well. So 5 over 1024. Okay, or it's in fraction, it's in decimal. Then after that we can get the 15, so it's 80, then 1 over 4, 15 minus 1. Okay, so which means power of 14. And we can get our answer, which is 5 over 167777216. Okay, so that's pretty much the part. Okay, so now example 6. Okay, number 6, for a geometric sequence with A equals to 2 and R equals to 1 over 4, find out the expression for the n term in terms of n, so which means they want the general formula, and find that which term is equal to 1 over 32,768. Okay, so now we have A equals to 2 and R equals to 1 over 4, right? So Tn is equal to ARn minus 1, because the question already gives us that it's a geometric sequence. So that's why 2, and we have 1 over 4 and n minus 1 here. What is it? So n minus 1. Okay, so we can just leave our answer here. So the question wants us to find out what is a term that equals to 1 over 32,768. So that's why it's the Tn will be equal to 1 over 32768. Okay, so let's try to solve it manually first. So we have 2, 1 over 4 n minus 1. So you will need a bit of knowledge in your indices. Okay, so you bring the 2 over, then it becomes divide 2, right? So 1 divide 1 over 32768 divided by 2, and you will be able to get 1 over 4 n minus 1 equal to 1 over 65536. Okay, so after we get this, how can we solve this? Yeah, so you need to equate them into the same base. So it means in this term 1 over 4 n minus 1, because it's equal to, so that's why we certainly know that we can try to write this into 1 over 4 of 1. So you can just try to use your calculator to actually calculate that. So you can just try out a different number, then you will be able to see that when you try out up to 8, then you'll be able to get the same value like this. Okay, so which means you try to type in 1 over 4 power 8, then you should be able to get this. So you know that when you try to change this to the base of 1 over 4, this is what you get. So as long as you have the same base already, so n minus 1 is equals to 8. So that's why n is equals to 9. Okay, so this is the idea of you calculate it by using your knowledge in indices, and also some how do you press your calculator and so on to get that right. So now I'm going to show you normally this kind of question you will use your TI Inspire to actually help you to solve that. So how can we do that? So let's try to key in the number that we have. Okay, so the same thing, we try to generate a sequence. Okay, so menu, data, and generate sequence. Okay, so 2, So you see you need to press fraction, right? So that's why this one. So 1 over 4 to the power of, then remember bracket, n minus 1. Okay, so after you got this, then the initial term is given as well, which is 1 over 4. So same thing is a fraction. So that's why 1 over 4. Okay, now you can just tap everything. Do I put in the wrong thing? Sorry, the A is 2. My mistake. Okay, 2. Okay, then after that you tap everything until you press OK. Okay, then you can get everything of this. Okay, but you realize that's one problem because in our calculator by default, your calculator will actually show it in decimal. So how are we going to do that? You need to go out of the document, then after that, reset the menu. Okay, so you can just go out then off everything. Okay, so which means I'm just going to open a new dot, right? File new. Okay, do not, I mean, if you do not need that, then you do not really need to solve. Okay, so now we just escape, then go out. Okay, so control escape, then you can go back to the menu which you normally, when you turn on your calculator, then this is what you get. Okay, then try to do it one time. If let's say you didn't follow just now. Okay, so if you're pressing a new document, then it will come out like this, right? So what I want you to do is you just don't follow this anymore. So you escape it. Then what do we need to do is go back to the menu. So that's why you just control escape. Then you will just go up. Okay, so now go to the settings. So in your calculator, you can press tab or you move the cursor. So you tap until you go to setting. Then you press enter. Okay, so now what do you need to do is document setting, number 2. So after you go to document setting, then this is the part where, okay, float 6 tell you that how many number that you show if let's say that's like digit. That's like more than how many digits, then they'll try to change it there. So I mean normally we don't use that much, so only this part, the calculation mode. So do you need your answer approximate? Is like how you get a decimal. So just now it's decimal, right? So that's why our calculator is all in approximate. So auto is like the calculator will just set it for you. Lah. Exact, then the calculator will actually show the answer in terms of fraction. So for this question, we need fraction, right? So that's why we can change it to exact. Okay, then just tap everything. Then after that, okay. So you need to remember how to do because later when you need decimal, then you need to come back and change to approximate. Okay, then okay. So now you try to do it again. So open a new document. So list and spreadsheet. So now we key in the exactly same thing and see what happened. Okay, so 2, 1 over 4. 1 over 4 and then power n minus 1. Okay, initial term is 2. Then now we just type everything, then okay. So you see all your answer now is in terms of fraction now. Okay, so let's check our answer. So you need 1 over 32768, right? So that's why it's the 9 number. So you can see it's the same answer. Okay, n equals to 9. So this is one method that you can try to do. Okay, so I'll write it here. So calculator you have. So this is the first method, manual calculation. So second is that you use your TIN Spire, then you remember to change it to exact. I mean, in this term, if let's say they try to give you a decimal, then you need to use approximate. So you use the sequence generate, right? So that's the second method. Okay, the last one I want to say that your calculator can actually help you to solve the equation. So number 3. So TIN Spire also, but you are using solving. TIN Spire. I'm sorry for that. So okay, yeah, you understand it as calculator lah. So TIN Spire, we are going to solve equation. So how can we do that? So same thing, we switch on our calculator. Okay, so previously, all the thing that we use is like list and spreadsheet and also data and statistic, right? So now I want you guys to open a new page and then after that add calculator. Okay, add calculator. Then after that, what we need to do is we need to key in this formula here. So meaning after we substitute, then we get this, right? So we need to solve the n. So we just find out what is n. So how can you solve in your calculator? You just press, oops, sorry for that. You just press and solve. and solve. Okay. Let me try to open it a bit bigger. Yeah, and solve. Then now you open your bracket, then you type in whatever is here. So 2, 1 over 4, right? Okay, so you can use the, okay, I think it's a bit too fast. So 1 over 4, you just press here. Okay, yeah. 2, open a bracket, then you just fraction 1 over 4, right? What you want. Okay, then after that to the power of n minus 1, so n minus 1. So this is exactly what you type here. Okay, then you go down again, then equal to, what do you have on the right hand side is 1 over, so that's why it's a fraction also. So 1 over 32768. So after you type in everything, then the variable that you solve here is n, right? So if let's say this is a, then you're going to type a. So in this case it's n, then you're going to just put a comma. Okay, you can see a comma here, right? Yeah, a comma. And then after that, press N. Okay, then what we're going to do next is just press Enter. Then you will straight away get your answer at the back. So this is how powerful your TI Inspire is. So later we are going to use this to solve simultaneous equation as well. Okay, so this is how you can do it by using the NSolve function in calculator. So solve equation, use the function of NSolve. Okay, so now move on to example 7. Okay, question 7. So for the geometric sequence here, 5, 10, 20, 40, the question wants us to find out what is the term of the sequence is the first to exceed. Oh, this is like 1, 2, 3, 4, 5, like 1 million. Okay, so state the number. Okay, so same thing, we need to find out what is our n term first. So A is equal to 5. So in this case, our R is equal to 10 divided by 5, right? So we can get 2 here. So when we write our n term in terms of n, then it will be 5, okay, A, R, n minus 1. So after we get that, then the first exceed 1 million. So that's why the n term is greater than million. So which in other words, 5, 2 n minus 1 is greater than million. Okay, so in this case, then you also need to use some knowledge in. Let's try to do manually first. Okay, so we have 2 power of n minus 1, and when you divide it, then you can get 200,000. Okay, so after we get this, then how are you going to solve this? So we can't do it like just now because you can't actually get a number that's like base 2 that give you 200,000. So you need something that is log. Then you realize that you do not be able to do that because I believe majority of the class do not take additional mathematics. So you actually do not need to solve this by using manual calculation. Okay, so that's why no need manual calculation because you do not have prior knowledge in uh, law. So that's why if this kind of question come out, they actually expect you to solve the first one by using what you have, the sequence generator, or you use solving the equation. Okay, so let's try to solve the equation first because we already have the equation here, right? So solve equation. So same thing and solve. Okay, so we are going to type in this in our calculator. So same thing. I hope that you are still keeping your calculator page, right? So what we need to do is we press the same thing, but then the greater sign, we just change it to equal to. So that's why and solve. Okay, so now 5, 2, and then to the power of n minus 1 is equal to 1 million. Okay, then you are solving n also. Okay, then enter. So you will be getting a decimal number because like what we said just now, there's no something that you can get an exact value with base 2. So that's why it's logical that you should get a decimal answer. So that's why your n should be greater than 18.61 maybe. So n will be greater than 18.61. So that's why what is the first term that is first exit, then it will be your n is when n is equals to 19. So how can you find that? Then you substitute back Tn equals to 5, 2, and then n minus 1, right? So 19 minus 1, then we'll be able to use our calculator. So 5 to power of 18. So you can see that you get 1310720, which this number is like greater than 1 million. Then you know that's correct. The other thing that you can try to check is now in your calculator, let's try to change 19 minus 1 to 18 minus 1. So you can find 17. So you will be realized that when you try to find, sorry, I should write 19 here. Okay, so this is extra one. So you see when you try to type in your calculator for T18, right, it will actually give you 655360. So that actually proves that your answer here is correct because for this number, it didn't exceed million yet. But when it's 19 term, then it's the first time that your sequence starts to exceed 1 million. So that's why by finding this, then to prove that your answer is correct. Okay, second is the same thing just now. You can just use your sequence generator. So this one is easier and normally is the normal approach that we try to use. Okay, so same thing in our calculator. Let's try to generate the sequence. So you can go back to the page. Remember how, right? So control, then just go back. Okay, so now let's try to generate the sequence. So data generate sequence. Okay, so in this case, what's the, so yeah, you need to type in this, right? 5, 2, and then to the power of n minus 1. Okay, initial term given is 5. So you just press OK, right? I hope that you are following. Okay, so after you get this, then you need to scroll through. So where is the first number that you have a number that's greater than million? So when you continue, yeah, so you see that this is the number. So that's why it's the 19 number. So by looking at this, then you can actually see the answer as well. So how do you answer this? Normally, we will try to write down two terms as well. Because like what I say, how do I know that this is the first term is the previous term hasn't exceed yet? So that's why when you try to write down, you need to write 2. So from the calculator, then we can get the T18 is actually equal to 655360. Then after that, T19 is already 1310720. So that's why T19 is the first one to exit your million. Okay, so that's the answer. You can try to write in full. So that's why T19. The idea is you must write down T18 also. Okay, if you are using this one, then it's okay because you are trying to use solving, right? So n is greater than 18.6, then obviously your n should be 19. But if you are using this one, then to prove that, how do you know this one is the first one? It's by proving that your previous one hasn't exit. So that's why you need to write both. Okay, so now example 8. Okay, example 8. So this is a bit similar, but then the question wants to find out what is a term that first becomes lower than 10. Okay, then state the number. So the same thing in this case, you can see that the A is equal to 5,000. Okay, so when we want to find out our R, it will be any term, right? Then divide by the previous term. Okay, so you can have 1,200 and 50 divided by 5,000, then that gives you 1 over 4. Okay, so it's either you want to do 1 over 4 or you want to do 0.25, so it's your own preference. Okay, so now then let's try to write down the n term first. So the n term here will just equal to, no matter you are using big N or small n, it doesn't matter, okay? So AR n minus 1, right? So our A is 5,000. So our R here is 1 over 4 and then n minus 1. Okay, so in this case, we want to find what's the term that first becomes lower than 10. So which means when our term become lesser than 10. Okay, so which means 5,000 and then 1 over 4 n minus 1 lesser than 10. Okay, in this case, you also know that you need some knowledge of logarithm to solve that. So that's why you can just leave it to your calculator. Okay, so now same thing. Let's try out with the n solve first. Okay, so you can go back to your calculator page, control, then go to your right. Okay, so same thing, n solve, then we try to put in the value that we have. Okay, so 5,000 Then after that, 1 over 4, right? So go to your fraction, then you just put in this. Okay, 1 over 4. Then after that, close it. Oops, sorry for that. 1 over 4. Okay, then power n minus 1. So you're just putting the whole thing the same, but it's just that the smaller than, greater than, don't care about that. So equals to 10. Okay, same thing. The variable that you want to solve here is also your n, right? So comma, then n. Then enter, then you should be able to get your n value. Okay, so the n that you get is 5.48. So same thing when we go back. So n is greater than 5.48. So which means that the first term that is lower than 7 is like the term after the 5.48 term. So which means the number that we get should be n equals to 6. Lah. So in this case, then you can always try to check out as well. Try to find out what is your T6. So T6 is equal to 5,000, right? Then after that, 1 over 4, and then 6 minus 1. Okay, so we can try to just calculate it by using the calculator. So multiply 5,000, then you can get 4.88. Okay, so that's number, the number is like very logical. So this is a number that's lower than 10, right? Okay, so like what I said previously, so we can always try to find out the previous term to see whether this answer is correct or not. So same thing, we can try to check for the fifth term. So when you try to substitute 5 into n, then this is going to be 5 minus 1, right? And by calculating it, then you'll be able to get 19.53. So that proves that this answer is like a correct one, because at the fifth term, your term is still lower, is still higher than 10. So T6 will be the first term that becomes lower than 10. Okay, so now we'll move on for the second method. So no matter you are using which method, you still need to do this. Okay, so this is by using the first method, which you use and solve. The second method, which is much more, I think it is much more favorable in the sense where, I mean, no matter its accuracy or what, then it's faster as well. Okay, so you want to find the first term that's lesser than 10. So you just try to generate the sequence in your calculator. Okay, so before you do that, you can see that all this term, right, even with one lower than 10, it's easier for us to deal with a decimal. So that's why when you go to your calculator, then you remember to go to change back to your approximate. Still remember how to do that, right? So control, then exit. Yeah. Okay, then go back to your setting. Then after that, document setting, then change your calculation mode back to approximate. Okay, then after that, then only you create. If not, then when you try to create the list and spreadsheet, you are going to get a list of fraction. Then it's going to be very hard for you, because you still need to check one by one, like which one is lower than 10, which one is higher than 10. So that's why it's easier to change back. Okay, so now same thing, data, generate sequence. So now let's key in the sequence here. So 5,000, okay, 1 over 4, power n minus 1. Okay, so initial term here is 5,000. So let's generate it, okay? So when you try to check, then this set of number must be the same with what we have here, right? Yeah, if it's not the same, then you will need to check it again, like is there anything you type it wrongly? Okay, so you check then which one is lower than 10. Yeah, so that's why it's correct with your answer just now. You see 4.88 is the first one. Then after that, T5 is still 19.53. So if you are using your calculator to do that, like what I said, you must write down two terms so to show that that's the first one. So you need to write down T5 is equals to 19.53, and after that T6 is equal to 4.88. So that's why the first term that becomes lower than 10, it should be equals to T6. Okay, so T6 is the first becomes lower than 10. Okay, so that's the idea how you should answer this. And the number is 4.88. Okay, so now let's look at the last example. Okay, example 9, find the 20 term of a geometric sequence for which the third term is 2 and the 10th term is 4, 3, 7, 4. Okay, so what do we need to do is we are going to use, so I'm going to show you two different way of doing it. Okay, so the first one is if let's say you want to calculate one by one. So which means in a form where, okay, this is method one. So what you want to do is you can calculate from T3 and then until your T10. So which means your T3 here is 2, am I right? So that's why you're going to have your T4, T5, T6. But this method, right, is a bit difficult if let's say you are having, if let's say the difference between, okay, if I give you the third term and the 100th term, and if you want to solve it like this, then it will be a bit difficult, okay? But this is something that you can do lah. So you can imagine from here to here is multiply 1r, right? So 1, 2, 3, 4, 5, 6, 7. Okay, so from here you know that from 2 to reach until 4, 3, 7, 4, you need to multiply 7 times of r. So that's why 2r7 will be equal to 4374. Okay, then you can use your calculator to help you to do that. So 4374 divided by 2, and we can get 12187. Okay, so this one you can just use your calculator as well. The is a root of 7. Okay, so 7 then root 12187, then that will give you 3. So that's why you can actually find out the common ratio already. So after you get this, then you still need to do your n term, right? So that's why the question gives you that the third term is 2. So that's why T3 is equal to 2, right? So what's the third term is ARN minus 1 equal to 2. So the A we don't know is what we want to find, right? But we know the R is 3 already. So n minus 1, the n here is 3. So that's why 3 minus 1 equals to 2. Okay, so now let's try to solve it and see what can we get. So 3 to the power of 2, then we get 9. So which means 9a equals to 2. So which means this term actually start from a equals to 2 over 9. So after we get this, then now we get our T20. So T20 is equals to ARN minus 1. So AR, then n minus 1, which is 20 minus 1. Okay, so you can just 2 over 9, then after that 3 power 19. So you can get your answer as 2582 80320. Okay, this method will be more on to solving an equation. It's like algebra kind of thing. Okay, so you are using two information to help you to get your R first, then by using n term of root to get your A, then after that you substitute back. Okay, so I wouldn't recommend this a lot because it involving some manual calculation of, from T3 to T10 is like multiply 7 times of R. So this one I not recommend so well. So now I'll try to do the second one, which you are going to use your simultaneous equation to help you to do that. Okay, let me try to use the other color. Okay, so this is method 2. So the same thing, but now how are we going to do it is that we already know that Tn will be equal to ARN minus 1, right? So that's why the first information gives us that the third term is 2. So that's why T3 gives us 2. So when we try to substitute here, then what can we get? So A we don't know, R we don't know, but now we know that n minus 1 is equal to, n minus 1 is just 3 minus 1, am I right? So 3 minus 1. So T3 is basically A, R, then 3 minus 1, right? Then equals to 2. So I get my first equation, which AR power 2 equals to 2. Okay, I hope that you are following. So I'm using this. So now second information, I have the 10th term is 4374. So the 10th term is 4374. So same thing, we try to build AR n minus 1 because we already know it's a GP, right? So A we don't know, R we don't know, n minus 1 is 10 minus 1. So equal to 4374. So now AR power 9 equal to 4374. So I hope that by this time you can see that this is basically a simultaneous equation and you should know how to solve this, right? Yeah, okay, so there's two ways that you can do out of it. The first one is I think this is easy, so you should know how to solve it by using a normal calculation as well. So if you are solving it, then we are going to use the second equation to divide by the first equation. So we have AR9 divided by AR2, which is 4374 divided by 2. Okay, so indices A and A cancel off each other. So R9 divided by R2, it gives you R power 7. And then 4374 divided by 2, and you have 2187. Okay, then you go back to the same thing like your number one as well. So this is how you solve it. And you will get your R equals to 3. Then after that, you substitute back into 1, right? So AR squared equals to 2. So now you already know that your R is 3. So A 3 squared equals to 2 and 9A equals to 2. So that's why you can get A equals to 2 over 9. It's the same answer like your method 1 just now. Okay, if in this case you want to use 2 also, you will get the same A1, so don't worry about that. Okay, so this is by using your knowledge of algebra and indices. So now, the other thing that you can have, calculator. Okay, so TRN Spire can actually straight away help you to solve this equation. So now, let's go to our calculator. Okay, so I want you to open a page of calculator first. So just open a new page, then add calculator. Okay, go to your menu and you can see that something like algebra. So after you open the algebra, right, then you can see that this something solve system of equation. Okay, then you just press solve system of equation, then you just press. Is it okay? Yeah, let me try to do it again. Algebra, solve system of equation, then number one, solve system of equation. Because this is not linear, we cannot use the second one. So for arithmetic, then we use the second one if you remember. So yeah, one. Okay, so how many equations that you have in this case? You have two, right? So the first one and the second one. So number of equation, we are going to put two. So the variable here is A and R. So we just change it to A and also R. Is it okay? A, comma, R. Then after that, what do you press? You just press OK. Then the calculator will come out like this for you. So what we need to do is just pressing it in our calculator. So let's key in. So A, so you remember you must put in times here. If not, there will be error in your calculator. Remember that. So A times R, okay, and then power 2, okay, then equal to 2. So that's our first equation here. So now move on to the second one. So A, then times as well, then your R power 9, then equals to 4374. Okay, so after that, when you have this thing, then you just enter in your calculator and the calculator will show you the two answer. Okay, and this is basically what we have found just now. Then we just write down your answer lah. Then R equals to 3 and then A equals to 2 over 9. This is by using, okay, let me just try to write down first. Yeah, solving system of equation. Okay, then you'll be able to get your A. The calculator actually give you R is 3 and A equals to 2 over 9. Okay, but the same thing, no matter you are using 1 or 2, you still need to do this. It's just that for this part, you are solving it manually. For this part, you are like solving it simultaneously by using your calculator. Okay, so no matter which one you are using, you still need to write this. Okay, so this is much more preferable than the first one. So I mean, both is the same now. It's just that whether which one you like to use. Okay, then after that, we can move on to get. I think the question one is to find the 20 term, right? Then you still need to continue. So T20 will be equal to ARN minus 1. So the A is 2 over 9. Okay, R is 3 and then n minus 1 is 20 minus 1. Okay, then we can straight away get this value. Then to get our answer, 3 to the power of 19 and then multiply 2 over 9. So you will get the same answer as what we got previously. Okay, so that's pretty much of it. So I hope that you can get the different method and you'll be able to have a better understanding on I mean, all this value, all these different method, you should be familiar with it. But normally, if let's say you have a calculator to do that, normally you can just press everything in your calculator to help you to get the answer. Okay, so that's pretty much for this lesson. Sorry, it's a bit long because of the explanation. So if let's say you have any question, then feel free to just ask me. Okay, so thanks for watching. So see you after your break. So enjoy your holiday. All right, thank you.